Welcome and hello. This is a video exercise in HEC-RAS, and in this exercise, we are going to be dealing with rules for lateral structures. Rules is a boundary condition, and we're going to demonstrate how that works with lateral structure gates in this exercise. All right, I'm going to bring up a problem statement to start off here, and it is right here. Sorry, it's a little bit long, but it is going to give us a good direction for this exercise. During a 3-day simulation, Farmer 1 has senior water rights of 1,000 CFS, Farmer 2 has junior water rights of 1,000 CFS to divert water through their lateral structure gate from the main channel. Due to in-stream flow requirements, no diversion can be made if the river flows below 3,000 CFS, and no diversion can be made if that diversion causes the river flow to drop below 3,000 CFS. All right, so anyway, here's my HEC-RAS. We're going to revisit that problem statement once we get some stuff built and then run the simulation, look at some results. All right, so first things first, file, new project, and then let's go ahead and navigate to the directory we want to save this project in. I'm going to go to exercises, 23, project, and now I'll just call this exercise 23. Okay, so I'll click OK, and then click OK to the unit system right here. All right, first things first, I got my geometric data editor already opened up here. So if you don't, you can just click on this button here or click edit geometric data. I'm going to click on the river reach and then just start by single left click at the upstream end of the river reach and then drag the mouse down to the next location. Continue making clicks if you want to add some curvature, and then finally a double click at the bottom of the reach. I'm going to call this river A and then reach 1. All right. Then I'm going to click on cross section, and then here's my cross section editor. I'm going to click on options, add a new cross section at river station 0. Right here is where I define the station and elevation data. So I'm just going to paste in the data I had copied onto my clipboard, but you can also type the values in right here. And then since this is the bottom of the reach, I'm going to just use 0 for that length downstream. And then Manning's end values, and then the overbank station. Okay, yep, that's good. So I'll click apply data. Over here on the right, we have a view of the cross section at river station 0. I'm going to go ahead and add a few more river stations. The total length of this channel is going to be 5,000 feet, so just under a mile. So I'm going to copy the current cross section, 1,000 feet. Each will be the distance between these main cross sections that I'm manually defining. Okay, so I'll go ahead and paste that in here for the distance to the next downstream river station. And I'm also going to add some elevation. So 2 feet would be good for a 0.2 slope. I'm going to continue this process 5 more times, so I'm up to 5,000. And adjust elevation and 2 feet and apply data. All right, so I off camera went ahead and did all the cross sections. So if we scroll through them here, this is river station 0. You can see the elevation is changing by 2 feet for each cross section. River station 1,000, 2,000, 3,000, 4,000, and 5,000. Okay, so I'll close that. We have the cross section showing up on the map here. Next, what I want to do is add some intermediate cross sections. So maybe every 500 feet, I can go Tools, Cross Sections. This is just going to interpolate between the manually defined cross sections that I've already added, and then interpolate and close. Next, I'm going to add a lateral structure. In fact, 2 lateral structures. The first will be down here at River Station 1900, and then further up at 3900. Okay, so let's go ahead and do that. Lateral structure is right here. And then the first thing we need to do is options, add lateral structure. I'm going to do this downstream one first. This is Farmer B, which has junior water rights, but we'll get to that a little bit later. Okay. And then for weir and embankment, okay, what I'm going to do here is say the weir width is 50 feet, and then the distance downstream right here is 100 feet. And then for the station and elevation, I have some values typed in here, 32, 0, up to 52. Okay, let's see what that looks like. I'll click OK. This is going to be next to the left overbank. And for the tailwater, I'll just say out of system. Okay, let me close that up. All right, it shows up in the diagram. I need to add the gate though, so let me go back to the lateral structure. Okay, there we go. I'm going to add 3 gates. So I'll click on gate. It's all going to be part of the same gate group. So the discharge coefficient will be 0.5. For the height, I'm going to say each of the gates are 6 feet high, 12 feet wide, and have an invert of 35 feet. The length of the lateral structure, like longitudinally along the length of the river, is 100 feet. So what I'm going to do here is have three gates, like I said, one, gate two, gate three. I'm going to center the middle one at 50 feet, and then I will do equal offsetting for the gates one and three. That'll be at 35 feet and 65 feet. Okay, so let's click OK, see what that looks like. And it looks pretty good. And we can also see the channel invert as well as the overbank, which is the ground black and bank station red icons here in the legend. All right, that's cool. Now I need to create a lateral structure upstream 2,000 feet. So what I'm going to do that is just start with what I already have built here and go options, copy lateral structure. This is going to be for farmer A, 3,900. Click OK. And now I just need to modify a couple elevation values here. So I'll start by clicking on the Weir embankment and then just increasing these elevation values by 0.2% slope, 2,000 feet upstream. So I think it's 4 feet. Let's go ahead and change the 32s to 36s and the 52s to 56s. Okay. And then OK. That looks correct. I still need to correct the gate elevation though. That's the invert. So 35 becomes 39. And okay, we're good to go there. Okay, so I'm going to save the geometry file by going up to File, Save Geometry Data. I'll just call this Base, and okay. Next, it's time to edit our unsteady flow data. I'm going to go up to the Edit menu here, Unsteady Flow Data. And now what we need to define is the boundary conditions for the bottom of the reach, the top of the reach, and then our two lateral structures. So let's start with the bottom of the reach here. I'm going to use the normal depth and then just type in the friction slope. Okay. For the two control structures, the lateral structures with gates in them, I'm going to start off by just assuming that they're closed for the entire simulation, run a base case to make sure the simulation works, and then come back and add the rules here. So it's kind of boring, our first run, but I just want to make sure that the model works. All right, so let's go ahead and do that. For this lateral structure at River Station 1900, I'm going to click on Rules. And then for the gate opening rate, I'll say that's 1 foot per minute opening, 1 foot per minute closing. Maximum is going to be 6 feet because the height of the gate itself. Minimum will be 0, which means it's closed. And then initial will be closed. Initial opening is the only field here that's required. Just leave it at that. Not going to add any rules or operations. So click OK. And then I'm going to do the same thing here for the lateral structure at River Station 3,900. So rules, and then again, 1, 1, 6, 0, 0, and OK. All right, finally, we have our upstream boundary condition. This is at the top of the reach. I'm going to go and define a flow hydrograph. I'm going to use the simulation time option here, as well as a 1-hour time step, and then just type in or paste in my flow values right here. Over in Excel, I've synthesized a 72-hour hydrograph that I'm going to use for this exercise, and it was randomly generated or pseudo-randomly generated by Excel. So I pasted it in, and this is what it looks like right here. It starts at 4,000 CFS, it ramps up to 6,000, down to 2,500, back up to 6,000, and then ends. So definitely some randomness going on there. All right, so I'll click OK. Now I want to save this unsteady flow data. And so I'm going to go File, Save Unsteady Flow Data, and I'm going to call this 1K7K random one closed. Closed represents the gates are going to be closed. So next time I save this type of file, when the gates have rules, I'll just replace this with rules. 1K to 7K is the range of flow rates that is coming in from the top of the reach, even though I don't think either of these max or min limits are actually hit. All right, so I'm going to close that. Now let's go ahead and create a plan, run the simulation, and just see what that looks like. So close, and then unsteady flow analysis. Save this plan here. Okay, and then okay. Let's turn on the programs to run. And this is a 3-day simulation, so I'm going to type in, I'll just use the first 3 days of the year. This is kind of my go-to 3-day simulation time window. Okay, that looks good. And then let's see the output down to the nearest 15 minutes. So 4 times per hour is a little bit more precise and detail than just once an hour. All right, File, Save Plan, and Compute. Okay, that finished up. So I'm going to click Close here. Let's look at some results and then get on with the rules. So View, Cross Section. I'm not seeing any Um, okay, I was not seeing any results because the post processor checkbox was not on. This is the step that actually writes the data to the results, the different paths to the DSS file. So made a little boo boo there. Just thought I clicked it, didn't save plan and compute. Okay, now let's click close. Let's look at those results. View cross-section data. That looks better. This is at the top of the reach now, river station 5000. So if we go ahead and animate that through, we see the water surface level is rising and lowering based on the change in flow. And then really not too exciting. Every cross-section is going to look something like this. Let's go ahead and look at the stage and flow hydrograph and then get on with the actual rules. So this is the stage and flow hydrograph. What we're seeing here, this is at river station 5000. So we have the stage right here, and then we have the flow right here. The flow here is the vertical axis over here on the right side of the plot. If we revisit that problem statement, we read that there's a 3000 CFS in-stream flow requirement, and that neither of the farmers can divert water if the total flow is 3000 CFS or less. So it looks like that will happen for a short period here during the second day. But if there's 4,000, that means the first farmer, farmer one, that he can get all of his flow, his 1,000 CFS. And if the total inflow is 5,000 CFS, then both farmers can get their full 1,000 CFS diversion. All right, let's go ahead and move on. Okay, I'm going to go ahead and close the unsteady flow analysis dialog box, go back to the unsteady flow data. I'm going to go ahead and file, save unsteady flow data as, and then as I mentioned before, instead of close, I'm just going to call it rules. Okay, now is where we're going to add our rules for these two lateral structures. Let's do the first one first, the 3900 river station lateral structure. I'll click on rules. And then this data right here is all the same. We'll start it at 0 opening. That's fine. And now it's the process of entering and adding rule data here in this rule editor. I'm going to start with a comment, and I'm just going to say get diversion flow, and then we're going to get a simulated value. So the next row down, this is going to be a new variable. Of course, there's no variables yet. So this is going to be the flow rate, and this is going to be at cross section 4000. So there's that. Next, I'm going to define a variable for the diversion flow. I'm going to start by going math, and then this is going to be a new variable as well. D3900, that's the diversion through the lateral structure at river station 3900. So we're talking about the farmer one who has senior water rights. I'm just going to set that value equal to 0 and click OK. Next, I want to create an if-else branching structure. So I'm going to go down to the fourth line, branch if-else. I'm going to go with this first option here, if then. And then before I forget, I'm just going to add the end if, which is right here. Okay, let's define that conditional statement now. And what I want to do is say that if the flow rate Q4000, okay, is greater than, and then I'm going to edit this is the 3000 CFS minimum in-stream flow requirement. Then I can update that diversion value right here. So I will click on math, and then now I'm going to click on existing variable D3900. And now the expression here is going to be the flow rate and then minus 3000. Okay. Now remember, we have a maximum of 1000 CFS water rights. So it's possible if that flow rate was more than 4000, then the diversion is going to be more than 1000. We don't want that. So I'm going to go ahead and add another if statement here. If, yes, and then let me add the end if. Okay. Now I want to go ahead and say if that diversion at 3900, okay, is greater than, and then this is going to be a constant 1000, okay, then we will set that diversion to 1000. So I'll say math. Oops, got in the wrong spot here. I got to click here. Now click math, and then existing variable again, D3900, and then I'm just going to set this equal to 1000. All right, now what we want to do is set the gate flow through that lateral structure to this value here of D3900. So let's go ahead and start with a comment. This is going to be set gate flow. Okay, next line down, I will set operational parameters and then scroll down here to gate flow desired. And then this is going to be the variable, which is D3900. All right, so this is the rule set for our lateral structure at River Station 3900. I'll click OK, and then I'll click OK. Actually, hold on. There was a button here to check rule set. No inconsistencies found. Okay, just wanted to make sure that that worked. I'm going to go File, Save Unsteady Flow Data. Now I need to do the same thing for this lateral structure at River Station 1900. So I'm going to do that, but less talking and more typing. Okay, so rules. Okay, I got the rule set all done for lateral structure 1900. You can read it here. It's basically instead of Q4000, it's Q2000, the flow at River Station 2000. And then I'm looking at the diversion for 1900 River Station, not 3900 River Station. And then lastly, I also needed to define the gate group for the first rule set at River Station 3900. So I did that there, and I did it here as well for the lateral structure at River Station 1900. All right, I think everything's ready to go. Let's go ahead and run the simulation and see what happens. So I'll click OK. Definitely going to save this. Then we can go ahead and close this dialog box. Go up to Run Unsteady Flow Analysis. Okay, so now we're using the rules flow file. That's good. And the same base geometry file. I'm going to go up to File, Save Plan. And now I'm going to save it as rules for my suffix there. Okay, same thing with the short ID. And click Compute. Okay, so that looks good. No warnings, no errors. Let's see what the flows look like. Stage and flow hydrographs. What I want to do is change the type to lateral structures. So this is the upstream lateral structure at River Station 3900. That's fine. I'm interested in the flow, so I'm going to toggle off the stage data. And then I'm also going to toggle off the individual weir and gate flows. All right, I'm going to go ahead and add some color to this. So right click, lines and symbols, go normal line, and then let's make that thicker. Okay, and then upstream, no symbol. We'll make the line 5. Let's go normal, and then let's go with, I don't know, red. Okay, and then downstream, let's go with no symbol, normal line, and then let's go with the thickness of 5 again. And then for a color, let's go with blue. Okay, so this should be a little easier to see. Okay, perfect. So what we're seeing here in red, this is the flow upstream of the lateral structure. And then in blue, that's the flow downstream of the lateral structure, where flow is right here on a scale of 0 to 7,000. And the difference between that red and blue line, i.e. the difference between upstream and downstream, is quite obviously the diversion amount, which is down here, this this green line, which is the diversion. So whenever this red line is above 3000 CFS, then the diversion should be at 1000, pretty much the same as 1000. And that's what we see here. However, right here for a short while, it dips below 3000 CFS, and that's when the diversion through this upstream lateral structure at River Station 3900 drops down to 0. Let's take a look at the lateral structure downstream at River Station 1900. So I'm going to toggle off weir flow and gate flow, and then I'm going to do the colors again. One moment. All right, so I got the colors fixed up. Now we're at lateral structure 1900. Remember, this is the junior water rights holder. This farmer B only gets to divert water, which is this green line here. Oh yeah, if it's 3000 or more, just like before. But the total flow down at River Station 2000 is most likely going to be less than it was upstream due to the upstream diversions. And notice that there's almost a day worth right here. This second day of the 3-day simulation involves 0 diversion because there's just no extra flow. The flow rate at River Station 2000 is not above 3000 CFS. One thing I wanted to do that I'm not sure how to do in HEC-RAS, at least not yet, is to compare some of these plots together. So what I want to do, and I'm going to use DSSVue to do this, is go ahead and take a look at the flow rate at River Station 5000, the top of the reach, and then the diversion for both lateral structure 3900 and 1900 at the same time, and then we'll call it good. Okay, so we got DSSVue up on the screen here. I'm going to go ahead and open and then navigate to the project. Here is the exercise23.dss file. And all right, now I've got 1,000 paths. I want to go ahead and filter. So I'll filter on the rules, and then hold on, let me scroll down a little bit. So the very bottom here, I'm going to go with River Station 5000 total flow. And then I also want river station 3900 lateral structure, total flow. And then 1900, the lateral structure, total flow is right there. Okay, let's go ahead and look at the plot. All right, this is cool. So now we have the total flow. It's in yellow. This is what we originally told HEC-RAS to use for an upstream boundary condition at that river station 5000. And whenever this yellow line is above 3000, then we're going to have a non-zero diversion out of red. This is the lateral structure or the diversion flow out of that lateral structure at river station 3900. And the green line here is the diversion through the lateral structure at river station 1900. All right, so that's the end of the exercise. This is just a way to demonstrate how to use rules to control gates at lateral structures to solve problems like this one.